Hello, 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 everybody, and welcome to Science this afternoon. I don't know if you can hear the sound of crickets chirping in the background, but that's the soundtrack that we are blessed with today because, thank you. No, stop it. Crickets don't listen very well. Anyway. Separating mixtures is what we're working on today. Yesterday, if you'll remember in our Intro to Mixtures lesson, we talked about a mixture in chemistry or in physical science being two things sort of mixed together and incorporated together. You know, milk and cereal being a very everyday example of a mixture there. Okay. Today we are going to define mixture again, test our possible methods to separate a mixture into its parts, and we will be able to define solution as it relates to physical science. It's a little different than sort of the answer to a puzzle, right? And then there's what you're going to need. Science notebook, pencil or pen. The table that we're going to need for observations is behind me. I will make it bigger so we can start to copy it down. So here's what our table is going to look like today. It's got 3 columns, well, 4 if you count the headers on the side. We've got gravel, we've got diatomaceous earth, and we've got salt. These are the 3 mixtures that we made yesterday. Here's our gravel. Here's what it looks like currently. Okay, still sort of gravel mixed with water. Very much separate because gravel is quite heavy and water, well, heavier than water, I should say. Our diatomaceous earth still looks like this. There we go. Put it on that side. Okay, kind of a cloudy, clear. If you remember, our diatomaceous earth is that powder. It's really silica. Comes from shells of tiny little single-celled algae called diatoms. You don't need to know that for this, but it's interesting. And then last we have our salt water. And here's what our salt water looks like. It just kind of looks like water. Our salt completely disappeared, and it just looks like water. Though if I were to taste it, which I won't because we are not tasting the science today, it would taste salty, like if you've ever gotten, you know, ocean water in your mouth, for instance, or, you know, pasta water at home. And yesterday, in yesterday's exit ticket, your job was to come up with possible solutions or possible ways we could separate out these mixtures back into their different parts. How we put them together, now can we get them apart? And there's a few different ways that we thought of. One was to use some sort of sifter, or, you know, you might have a sifter at home for, you know, sifting flour, or some sort of, we're going to call them today, screens. Okay, running our mixture through a screen, and I have a few different screens here. There's one. There's a second one. What are the differences between these 2 screens? If I look closer, yeah, this one's got bigger holes. This one's got smaller holes. And then we have this one here that has even smaller holes than the other 2. So varying size screens here that we're going to try today with our 3 different mixtures. And then we also had one of our ingenious scientists had the idea of, what if we just let them separate, and then we took our syringe and we took the water out? Would that work? Would we just be left with our diatomaceous earth or our gravel or our salt back in the container? We're going to find out. So we're going to try it with a syringe. Okay. And the last 2 we'll get to in a second. So we'll start there. So go ahead and copy that down in your science notebook. And then we're going to head on over to our testing table and start testing. Okay, let me move my scale off of the testing table because we don't need it yet. We're just going to use sort of our eye test and our visual observations today with these screen separations. So, yes, the screens do look like a bit like baking sifters. Very similar concept, right? Just a piece of mesh that it works through and separates out In the case of like a baking sifter, it's putting air into your dry ingredients so they're not as tightly packed. Flour's been kind of packed in the bag, and it makes it a little fluffier and makes your baked goods a little fluffier if you sift your flour first. All right, let's head on over to the testing table here. Let me put you down right here. Here's my box of salt. Okay, let me tilt down a little further. All right, so let me grab my empty bins here. And what we're going to do is we're going to start with, well, what should we start with? Here's our bin here. Move this out of the way because we don't need it yet. Move that out of the way because we don't need it yet. Starting here, we've got, well, should we start big, large, medium, or small with our screens? Why don't we start medium? Just in the interest of time. In a, perfect world in our lab scenario, we'd be able to test all three. But just in the interest of time, we're going to just go with the medium. I think that's going to be a good size. Well, let's start with our gravel. A lot of people said this one is going to work for the gravel if we pour it through. So let's go ahead and watch and see what happens. All right. There we go. Okay. And as we can see here, well, I do notice one thing. We've got a few of our smaller pieces of gravel that have fallen in because we used the medium-sized screen, but the majority, the overwhelming majority of the gravel was caught by the screen. So we can call this a yes. There is a little bit of water still here because of surface tension. It's still kind of stuck on the gravel, but if we were to leave it and left the rest of that gravel or the rest of that water evaporate off, we would end up back with our dry gravel again. Okay, so just for funsies, let's see the small screen. Let's see if we can't catch the rest of this gravel here. There we go. And look at that. Smaller holes means it catches that smaller gravel. We're only left with the teeniest, tiniest pieces of gravel in there. Okay, so if we go back to our big table over here, zoop, hello, thank you for coming on a journey. Sorry if I got your car sick. Gravel can be separated out using a screen. So we're going to put a yes there. Let's check our diatomaceous earth. I'm actually going to reset my gravel and water here because we want to test it with a syringe as well. So let me as carefully as I can here. There we go. All right, back mixed. Diatomaceous earth. Let's just go straight to the small screen. I feel like if the medium screen wasn't even catching some gravel pieces, the diatomaceous earth is going to need the small screen. All right, let's give it a mix. Make sure everything's incorporated in here. Tilt this down. And now we're going to pour it through and see. So if it does work, we should see clearish water down in the thing, and our diatomaceous earth has been caught by the screen. Here we go. That would, well, that looks like a pretty definitive no, doesn't it? We've got a little bit caught here, but really that's kind of the surface tension of the water catching and almost making sort of bubbles in between. But for the most part, we still have diatomaceous earth and water mixed. So that would be a no on that. So go ahead and give yourself a no there. And now let's try our salt water. I'm actually going to switch to a fresh bin here. There we go. All right, we've got our salt water. We've got our screen. Let me give this a quick tap, get the rest of the diatomaceous earth off there. There we go. Clean screen. salt water. So if this does separate, we will see clear water in the basin or in the tub and a bunch of salt in the screen. Quick, make a hypothesis. What do you think is going to happen here? All right, here we go. I don't think there's any salt in this screen. So I think we can safely say a no for that one as well. All right, next we're moving through. We've got our syringe. So we had the idea, one of our scientists had the idea to just let everything separate, and then we're going to take the syringe, put it in our water, pull that plunger back, and hopefully we can suck all that water out of there without sucking up any of the stuff we mixed, the material we mixed. Let's start with our gravel. Okay, I'm already seeing some hypotheses in the chat that we don't think this will work. Let's try it with the gravel, see what happens. Okay, so, I mean, we didn't suck up any gravel, so that's good. Let me this was one of our demos that I didn't measure the water, so there's more than 50 milliliters of water in here. Okay, still no gravel. That's a good sign. And we're definitely getting down to it. Let's see if I can get any more water out of here. Okay. And, well, I'll tell you what, that actually worked pretty decently. I mean, our gravel's still wet, but it kind of did get all the water out of there. And the hole on our syringe, this is kind of the key here, is the hole on our syringe, just like the hole in our screen, it's small enough that it can suck water up, but not so big that it'll suck the gravel up with it. So actually, this is an effective method of separating gravel. Interesting. And I see in the chat, the others seem really incorporated with the water because they have smaller particles. A lot of really good science vocabulary in there, and I would tend to agree with you. Okay, let's get the rest of the zero out our syringe here. Let's try the diatomaceous earth. All right, I have a diatomaceous earth that's been sitting for, this is the one we made yesterday, and I literally have not touched it since yesterday. So I'm going to carefully get it. Okay, there's our sample there. I'll tilt it back down in a sec. Okay, I'm trying not to pull everything down with my mic cord here. All right, let's try it and see what happens here. So we've got our diatomaceous earth. I'm going to put the syringe in. And the key here is I don't want to stick it all the way to the bottom where the diatomaceous earth is settled. Oh, this is just a tremendous noise. Okay, so take a look here. Take a look at the quality of our water. Okay, and I'm going to do a syringe full of water, of clean water, control water, just to see here. Okay, so let's compare the differences in water quality here. So here's the water, the clean water, our control, and here's our diatomaceous earth. There's definitely a difference in transparency, right? We do see here it's a little less clear. It's actually not too far off, but it's cloudy enough that it makes me think that the diatomaceous earth over here is still mixed up. Otherwise, it would kind of look this clear, truly transparent color that the water is here. So I'm going to go ahead and say no for this one, but I do like the idea, and it did kind of work. It did kind of work. It wasn't as effective as potentially some other methods, but it did kind of work. Okay, last one, salt water. Salt water in a syringe. If we take up all the water, will there just be salt left? Okay. Let me get a bin to put this in here. Taking the water out. Syringe it up. This is already looking, I don't know about this. I'm not seeing any salt at the bottom of this. Let's get the rest of the water out of here. Great noise. Love a good syringe squeaky noise. Okay. Do you see any salt at the bottom? No. I don't either. So I'm going to go ahead and say that this is a no. We've just taken salt water in the syringe and put it into this bin over here. We did not actually separate out the salt from the water. So currently, let's update our thing. We're coming on 17 minutes, so I do want to be quick because I don't want to make this too long. But we've got a yes, a no, and a no. For syringe, we've got a yes, we've got a kind of, and we've got a no. All right, so that's what we have so far. The last two ideas we had, okay, and for the sake of time, I'm going to tell you these are yes for gravel as well, are two different kinds of filters. We talked about wanting, a lot of scientists talked about wanting some sort of filter to filter things out, okay? There are two kinds that we're going to test today. The first one is, and you might have seen this if your parents are coffee drinkers, is we're going to test a coffee filter. And we're going to pour our mixture into the coffee filter, and we're going to let it filter out the bottom and see if just the water comes out and our solid is left in the filter. The other one we're going to try is a cloth filter. I actually just used a piece of t-shirt, piece of old t-shirt, and we're going to do the same thing and filter it through. We're going to do it with the diatomaceous earth, and we're going to do it with the salt water, and we're going to see if it filters out. All right, give me just 1 second to set that up. I'll bring you over here to the investigation table, and let's take a look. Da-da-da, da-da-da, coming through, coming through. All right, here we are over at investigation table number 2. Getting the stool here. Don't want to yank the entire computer off of the table. Here we are. Hello. Okay, so turn this way a little bit so we can see them all. There we go. Okay, so we've got our coffee filter, and we're going to do our coffee filter with our diatomaceous earth. I'm going to give it a stir again because it's settled a little bit, and I don't want it to be completely incorporated as I spray it all over myself. All right, pouring in to the coffee filter, and we'll see what filters through. Okay, in fact, I'm going to have to try that one again, but that's okay, because what I did is I missed a little bit, so I'm not getting as accurate results as I wanted. So, round 2. Luckily, I have extras of the diatomaceous earth samples. Okay, round 2 on that one. That was a bust, because I missed the filter. So, let's try it again. Here's that. Here's our filter. Here's our cup at the bottom. We'll use a clean cup. And diatomaceous earth. Stir, stir, stir. Again, if we were in the classroom, you'd be doing this yourself, and it would be a little bit more interesting, but I'm trying my best, so thank you. Okay. Here we go. Pouring, pouring, pouring. There we go. And now the cloth filter with our diatomaceous earth. And pouring in. All right, so now there's those two going. Let's move it this, nope, move it that way. There we go. Those two going, now let's get our salt water going. All right, first we've got salt water. This is, no. Here's our salt water. Salt water, coffee filter. And salt water, cloth filter. Okay, so while those are filtering out, because I am noticing the cloth takes a lot longer, let's take a look at our results here, because they are quite fascinating. In fact, I'm going to move the word wall here. There we go. Now we can see. All right, so now if we look at our diatomaceous earth samples, check out the water here. Clearer. Huh. Same with the coffee filter. Clearer. Now, what will we see in the filter if it separated it out? Let's take a look in our filters. Here's our coffee filter first. Aha! There's our diatomaceous earth. So it has separated it out with the filter. Did the cloth filter work the same? Oh, you bet it did. Look at all that diatomaceous earth sitting there. So we've got yeses for both filters. It did filter out. Again, it's not going to be 100% perfect, but it did filter out the diatomaceous earth. Amazing. So, oh, there goes that. So now, let's look at our salt water. So remember, we're looking for clear water, and then we're looking for evidence in the filter of, we should see some salt sitting in the filter. So first, we've got water looks pretty clear, but then again, it looked clear going in. So is there a bunch of salt in the coffee filter? No, there's not. Where'd it go? Who's to say? Did the cloth filter do it though? Water is clear. Do we see a bunch of salt sitting in our cloth filter? No, it's just wet. So we have a no and a no for our salt water, and a yes for our diatomaceous earth. So our finished, so we have coffee filter, cloth filter, okay? We had a yes, and we had a no and a no. Now, let's get to this last bit before we get out of here. Thank you for staying with us. I'm going to bring the word wall back up front. There we go. Now, we saw in this case, we saw our gravel and our diatomaceous earth. We were able to separate out those mixtures using a filter or a screen. We weren't able to do that with the salt and the water mixed together. And this is where our vocabulary bit comes in. Because when we are talking about chemistry or physical science, a solution Here's the definition of solution. Okay? A substance, in this case salt, mixed with water substance mixed with water, where the, sorry, I'm being distracted. Yeah, the exit ticket, if it didn't post, I'll post it right after I stop recording this video. A substance mixed with water, where the substance seems to disappear and it cannot be separated by a filter. So in this case, salt water, we would not, it goes beyond calling it a mixture. We actually call it a solution, saltwater solution, or you might hear saline solution, which is essentially saltwater solution, just in a particular proportion. Okay, and there are a number of different solutions, chemical solutions, physical solutions that we will take a look at. There is a way, however, to get the salt out of salt water. And many of you had that idea in your exit ticket yesterday. A few people said, well, if we wanted to separate out the salt from the water, what we could do is we could let the water evaporate, turn into water vapor, and in theory, what would be left behind is the salt. So what I'm going to do is I'm going to take some saltwater samples. I'm going to put them over here by the window where it's nice and sunny and gets warm. And we're going to see, and we're going to revisit that next week. And we're going to come back once they've evaporated, and we're going to see whether the salt really is left behind or did the salt evaporate along with the water. Well, you'll have to tune in next time and find out. All right, thanks everybody. If the exit ticket hasn't posted on Google Classroom, I'm going to hit post on it right now because there definitely is one. Okay, happy science, and we will see you at 2:15 for our mixtures share out. Remember, if you can think of or find a mixture around the house, we are meeting at 2:15 to share them out. This is a great excuse to sit and eat a bowl of cereal in front of the rest of the class and say, look, I found a mixture. All right, there you go. Happy science, happy mixtures. We'll see you next time.